Welcome to Omega Open Course. In this video, we will be discussing spherical coordinate system and how to transform Cartesian coordinates and spherical coordinates into each other. The spherical coordinate system has many applications in various fields, including geography, astronomy, mathematics, and physics. In high school physics, understanding of a spherical coordinate system helps a lot while dealing with good questions of gravitation, electric field, and other systems which have a symmetry about a point. To specify any point uniquely in a three-dimensional space, at least three independent parameters are required. We call these parameters coordinates. In Cartesian coordinate system, these parameters are distance of the point from three perpendicular planes which we know as x, y, and z coordinates. To understand the three parameters in a spherical coordinate system or spherical coordinates of a point, let us first draw three axes perpendicular to each other. Let there be a point in the space. Now let us draw a sphere with center at the origin such that it passes through the point. The first parameter is the radius of the sphere. If you draw a line from the origin to the point, the first parameter is the length of this line and is usually represented by r. The second parameter is the angle this line makes with the z-axis, called the polar angle, and it is usually represented by theta. Now let us draw a perpendicular from the point to the xy plane. Now join the foot of the perpendicular from the origin. The third parameter, called the azimuth angle, is the angle this line makes with the x-axis and is usually represented by phi. Thus the coordinates of a point in a spherical coordinate system is r, theta, phi. Now let us convert these spherical coordinates into Cartesian coordinates. From the point, draw a line perpendicular to the z-axis. Since the radius makes an angle theta with the z-axis, the distance of the point where this perpendicular meets the z-axis from the origin is r cos theta. But this distance is z-coordinate of the point in Cartesian coordinate system. The length of the perpendicular is r sin theta. Therefore, the length of the line from the origin to the foot of the perpendicular on xy plane too is r sin theta. Now let us draw perpendiculars from the foot to x and y axis. Since the line makes an angle phi with the x-axis, the distance of the foot of perpendicular on the x-axis is r sin theta cos phi. This is x-coordinate of the point in Cartesian system. Similarly, the y-coordinate of the point is r sin theta sin phi. Thus, when the spherical coordinates r, theta, phi is converted to Cartesian system, the coordinates become r sin theta cos phi, r sin theta sin phi, r cos theta. Now let us convert Cartesian coordinates x, y, z into spherical coordinates. As you know, if you draw a cuboid with three of its edges along the axis and one vertex on the point, then the width of the cuboid is x, its length y, and height z. The first of the spherical coordinates is the distance of the point from the origin, which is same as the length of the body diagonal of the cuboid. But the length of the body diagonal of the cuboid is root under x square plus y square plus z square. Thus the value of parameter r for the point is root under x square plus y square plus z square. The second parameter, the polar angle, is the angle the body diagonal makes with the z-axis. If you draw a perpendicular from the point to the z-axis, then we get a right angle triangle with base z, inclination theta, and hypotenuse root under x square plus y square plus z square. From trigonometry, we know that theta is equal to cos inverse of z by root under x square plus y square plus z square. Now draw a perpendicular from the point to xy plane and join the foot with the origin. The azimuth angle is the angle this line makes with the x-axis. The length of the perpendicular to the x-axis from the foot of the perpendicular on xy plane is y. From trigonometry, we know that phi is tan inverse y by x. Therefore, the azimuth angle is tan inverse y by x. Hence, the Cartesian coordinates of x, y, z has spherical coordinates root under x square plus y square plus z square, cos inverse of z by root under x square plus y square plus z square, tan inverse y by x. I hope this video helped you understand the spherical coordinate system. Check out our other such videos discussing theories and concepts of mathematics and physics. The link for the playlist is shown on the screen. Subscribe the channel, like our Facebook page, follow us on Twitter, and support us on Patreon. The links are given in the description. Thank you for watching.